now. Okay.
Also, the participants are increasing.
Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome all. Okay. Who is writing with us? Okay. Let me disable participants annotation. Okay. And now, good evening all. Thank you so much for your prompt response, honestly. And I'd like to welcome you to the first lecture that we're going to have online. At any time, if you have any questions, there is an option where you can raise your hand, okay? And at any moment, raise your hand and write in the chat whatever question you have, okay? And we will start now with our first lecture, which is high resolution manometry. Let's go. So what's the concept behind high resolution manometry? Let's draw the GI tract. Here we have the esophagus, and here we have the stomach and the pylorus. So in high resolution manometry, we will insert a probe through the esophagus and it will go to the stomach. This probe actually has at each single centimeter a pressure detector. So we'll draw at each single centimeter, there will be a pressure detector, and it will record the strength of the contractions. So there will be this curve going this way, and this will be the y-axis, and here we have the x-axis. So on the y-axis, each segment will correspond to the segment on the esophagus. And for example, this segment here will correspond to the lower esophageal sphincter. And this segment here will correspond to the upper esophageal sphincter. Make sense? On the x-axis, we have the time. As you recall, the peristalsis is a coordinated movement between the longitudinal and the circular muscles. And they have to contract and relax in a coordinated fashion in order to propel the food or the bolus of food. So the contraction will be going through the x-axis with time, okay? And it will be going down the y-axis as we descend through the esophagus. So how do we depict the strength of contraction on this esophageal manometry? Actually, we use the same colors that we used in geography when we were kids. Do you recall that the lowest point or the deepest point was the sea level? So this will be zero or no contraction at all, okay? This is zero power of contraction. Then we had the plane surfaces or the flat surfaces, which we gave green color. So this will be a very weak kind of contraction. Then we have the mounts, which looked like yellow or orange. And when we had the mountains, they appeared as red. So whenever the contraction is very strong, it will appear as a mountain or red. So let's start now. This here will be the tone of the upper esophageal sphincter. Make sense? It is tonically contracted. And here will be the lower esophageal sphincter. As you can see, they correspond to the same locations on the y-axis. So whenever somebody swallows a bolus of food, there will be a relaxation of the upper esophageal sphincter. This will be the first thing that happens. So the upper esophageal sphincter will relax. And here we can see the blue color, which depicts the relaxation or no contraction. Then the food will start going down and with time. And here we have the contraction of the upper segment of the esophagus, which is the skeletal muscle. Then as we go down, we have the contraction of the smooth muscle or the distal segment of the esophagus. Let's draw it here like a mountain, okay? So here you can see it as a mountain. And then when the food reaches here, the lower esophageal sphincter should relax to receive the bolus of food. So we will have relaxation, which looks blue here, to receive the bolus of food. So we have three conditions that we should meet in normal manometry. There should be this C here, which is the relaxation of the lower esophageal sphincter. And we should have this mountain here, which depicts the peristalsis or the contraction of the esophagus. And the last condition, this mountain should be distant from the C. Why is that? Because if this is not the case, this is what we call spasm. What is the definition of spasm? Spasm is a premature, rapid propagating contraction. So if this whole mountain was actually here, it means it is spasm, not peristalsis. So this distance, okay, somebody rose their hand. Okay. Firas, you can write your question in the chat and I'll answer it, okay? So this distance here, we take it from the beginning of the swallowing here till this point here. You can see the contraction is going very strongly, very fast, and then here it is slowing a little bit down. This point where the contraction decelerates, we put a point at it and we connect it with the beginning of swallowing. This distance here is called the distal latency. And the distal latency, if it is short, if there is no latency, this is a premature, rapid contraction, we call it spasm. Make sense? Okay. So let's proceed. I'll show you on the pictures. Okay. Okay, let's proceed. So as you can see here, the same concept, the strength of contraction pertains to the height of the mountain, okay? Does the spasm initiate when swallowing? So spasm is an unconscious process. It is premature, uncoordinated contraction, rapidly propagating. It's a disease actually where the smooth muscle will be contracting very rapidly. So yes, this is an unconscious process. Okay. Does that answer your question for us? So this is a 3D representation. It depicts the same thing. Here you can see the contraction of the upper esophagus. Here's a small relaxation where we had the C of the upper esophageal sphincter. Here is the contraction of the body of the esophagus. You can see it as a mountain. And lastly, here you have the relaxation of the lower esophageal sphincter. Are we clear about this point? Write yes in the chat if you are clear. Okay, Hijaziya, you can ask your question in the chat as we proceed. Okay, so as we said, you should have a C with a distant mountain. This is the normal manometry, okay? If we don't have the C, there is no relaxation of the lower esophagus. If you don't have the mountain, there is no peristalsis. And if the mountain is not distant, this is spasm. Make sense? Let me just erase those stuff as you write your question. Okay. Where is the relaxation? Oh, okay. So the relaxation, I'm going to show it to you now. Here, this C here, or the blue color, means no contraction of the lower esophageal sphincter. Again, I will show you yeah. Here you can see it again. You can see here the relaxation or the C. And here you have the mountain, which is the peristalsis. And here you have the distal latency. Let me draw for you the distal latency. So from this point where it decelerates to the beginning, let me choose another color. So I'll choose pink. So from here to here, you have the distal latency. Make sense? Okay. So let's proceed now after we have explained the normal. So as you can see in this example, let's look at the distance from here to here. Can you see that the distance from the beginning of swallowing and to the mountain is very short? This is spasm. So if this distance or the distal latency is short, it means it's a spasm because it's premature, it is very rapidly occurring, it's a spasm. Make sense? Okay. So let's discuss the first disease. The first disease here, let's look at the conditions that we said. The first thing, is there a C here? Right in the chat. Do you see a C here? Excellent. We don't see a C, right? So there is no relaxation of the lower esophageal sphincter. We have two differential diagnoses when we don't have relaxation. It is either an obstruction of the lower esophageal sphincter or it is achalagia. But for achalagia, we should have another condition to call it achalagia. It is not only absence of relaxation, there should be another thing. Write in the chat if you know what is that thing. Absence of excellent, excellent. Absence of peristalsis, yes. So this is what happens. There should be no relaxation, also absence of peristalsis. This is achalagia. In this example here, let's look. We don't have the C, that means no relaxation of the lower esophageal sphincter, but we can clearly see the mountain here, and the mountain is distant, right? It means this is normal peristalsis, normal contraction. The only pathology is the absence of lower esophageal relaxation. It means there is obstruction. Now let's compare this with achalagia. In the Chicago classification, we have three types of achalagia. The first one, here we don't see any C. That means there is no relaxation of the lower esophageal sphincter. But look, let's look. Is there any contraction or peristalsis? Right in the chat. Do you see any contraction or peristalsis? No. Excellent. We only see a blue color, which means no contraction. This is type 1 achalagia. So there is no relaxation of the lower esophageal sphincter, also absent peristalsis. Let's continue. So this is type 1. In type 2, again, we don't have any C, no relaxation of the lower esophageal sphincter, but we have these columns or bands. These are not normal peristalsis. It doesn't look like a mountain, right? This is actually called pan-esophageal pressurization. Okay, so let's take Ghadir's question. Ask in the chat. Okay, ask it as I continue my point. So what happens here actually, the longitudinal muscle of the esophagus, from the beginning of the esophagus till the end, will be contracting. They will not relax. All of them will be contracting at the same time. And recall that peristalsis had to have a coordinated contraction between the circular and the longitudinal muscle in order to propel the food. If the longitudinal muscle is contracting from the beginning of the esophagus till the end, this is just adding pressure to the bolus of food. And you will have this continuous wave of pressure on the bolus of food as the patient ingested. So this is not peristalsis, this is just pressure of the longitudinal muscles. Does it make sense? Right, yes or no? Does it make sense? Okay. Okay, I'll repeat quickly. So all of the longitudinal muscle from the beginning of the esophagus till the end are tonically contracting. So as the patient swallows, there will be pressure on the food bolus and it will look like a band or column. This is not normal peristalsis. This is type 2 achalagia. So in type 2, no relaxation with pressure of the esophagus, what we call pan-esophageal pressurization. Okay? So let's continue now. In the third type, there is no relaxation, no C. In addition, you might think that this is a normal mountain. Actually, it is not. Let's look at the distance from this mountain till the beginning of swallowing. Is it a short distance? If it is a short distance, what do we call it? Write in the chat. Short distance, spasm. Excellent. Short distance is spasm. Yes. So no relaxation of the lower esophageal sphincter with spasm. This is type 3 achalagia. So in review, in type 1, no relaxation with no peristalsis. Type 2, no relaxation with esophageal pressurization. And in type 3, no relaxation with spasm. Let me show it to you on a barium swallow. It will make more sense. Look here, look at the esophagus as it is dilated. There is no contraction whatsoever of this esophagus, and you can see the bird's beak. This means this is type 1 achalasia, as there is no contraction whatsoever. But look in type 2, it holds some shape. The esophagus looks like a cylindrical shape because there is this pressurization of the longitudinal muscle. And in type 3, let's look at it. You can see this tortuous esophagus, which means that this esophagus is undergoing spasm with the bird's beak. Make sense? Okay. And this summarizes achalasia. Can you point out the bird's beak? Okay. So as you can see here, here is the bird's beak, here is the bird's beak, and here is the bird's beak. Okay, makes sense? Let's continue now. Hijazi raised hand. Okay, go on. Ask in the chat before we proceed. If anybody has a question now, just ask it about achalasia so we can proceed to the next point. We're about to finish. Okay, so what is the definition of peristalsis? Peristalsis is a coordinated movement of the circular and longitudinal muscle. Peristalsis does not equal contraction. So in type 1, there is no contraction whatsoever. In type 2, there is contraction of the longitudinal muscle. In type 3, it's a premature, rapid contraction, which is spasm, does not equal peristalsis. Make sense? So this is the answer. And for Hijaziyya, what do we have? Columns? Because this is a pressure on the food bolus as it is swallowed. The longitudinal muscle will compress that food bolus and compress the probe. That's why you have these columns. The bird beak indicates that the lower esophageal sphincter is contracting. It is very narrow and it's not relaxing. So what is spasm? Okay. So let me show you here a spasm. Can you see this whole contraction, this whole mountain? It is occurring prematurely. This whole thing should be here. This whole thing occurred prematurely. That's why we call it spasm. Make sense? Did I miss any of your questions? For the jackhammer, just wait. We are coming to it. Just wait. What does the normal value is 4.5. Did I miss any of your questions? Okay, excellent. Let's proceed now, since we are all on the same page. Okay. So now let's look at this example. We have to evaluate the three things. The first thing is, do we see a C? The answer is yes, there is a C, right? So there is a relaxation of the lower esophageal sphincter. The second condition, is there a mountain? Yes. But look at this mountain. What do you think about it? It is huge. That means that the strength of contraction is huge. And even you can see the esophagus undergoing very forceful contraction here. Okay? Let's look at the distance. The distance is more than 4.5. That means this is not spasm, because spasm has to be premature, rapidly propagating. The only pathology here is the strength of the contraction. The pathology is the mountain itself. It is huge. That's why we call it hypercontractile or jackhammer esophagus. Jackhammer is the thing that we use to drill the roads. Okay, it's very forceful, very strong. Make sense? This is jackhammer. It is not spasm because it's not premature. It is just forceful contraction. Let's proceed to the second example. What do you think about this contraction? I want you to look at it. What do you think about it? Is it strong or weak? Right? Strong or weak? Very weak. Excellent. 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 It only looks like a plain or flat surface, right? There is no mountain. It's very weak. That's why we call it ineffective. Okay? This is the difference between jackhammer and ineffective. So one of them is very strong. One of them is very weak. That's it. Let's proceed to this example. Look here. Do you see a whole fragment of the esophagus not contracting? It just looks like a C. That means there is a whole fragment not undergoing peristalsis. We call it fragmented peristalsis. That's it. Easy? Let me see, what do we have here? Yes, the last thing is the hiatus hernia. Okay? Let me discuss with you the hiatus hernia. Let's look at it here. Is there a C? Yes, there is a C. Let me draw. There is a C, we can see it clearly. There is the mountain, and the mountain is distant from the sea. That means this is normal. But let's look at the abnormality here. Do you see another seashore? We have two seashores here. Not two seas, I would like to say two seashores, okay? شطين. Why is that? This first seashore corresponds to the lower esophageal sphincter. And the second one corresponds to the diaphragm. Actually, when we inhale, with every inhalation, the diaphragm will contract and will press on the probe. That's why we have these contractions as the diaphragm presses on the probe. Okay? And the distance between the diaphragm and the lower esophageal sphincter is actually the distance of the hernia itself. Because remember, the y-axis is the distance on the probe itself. Make sense? Any questions about the hernia? Yes, you are right, Ya Omar. You are right. Yes. And even, Ya Omar, you can calculate the respiratory rate from the islands down there. Any questions about hernia? Yes, we have two lines. That's the only abnormality. You're right. So usually this hernia, you have to have the lower esophageal sphincter displaced to have 2 points on the manometry. Okay. So any questions till now about the hernia, about echalagia? Ask now. And barium swallow. Barium swallow is very difficult to differentiate on the barium swallow because between spasm and the jackhammer. That's why we have the manometry. Okay. All of these motility disorders are best evaluated by manometry. But usually in jackhammer, it's more severe. Any other questions? Okay. So there is no such a thing as normal bands. There is normal contraction. Look at this beautiful mountain. This is normal, beautiful mountain, normal contraction. But this here, look at it. It's like a column. مثل الأعمدة الرومانية. Columns or bands. This is abnormal. Okay, I'll proceed to the last point here, and then we can address any of your questions. So the last point here. Here we have an artifact which is called the butterfly effect. So let me again draw for you the esophagus. Oh my God, sorry for this. So here we have the esophagus and the stomach. So here actually what happened, we went in with our probe, and our probe got coiled in the lower esophagus. That's why whatever pressure we recorded twice. So this segment here will record this, and this segment, which is coiled, will record the mirror image, which is this. Make sense? This is just an artifact where the probe is coiled. That's it. Okay. So this is just a mansaf, since this is the first session, and we had to bring food. Any questions? We will discuss the impedance study now. Let me just check. Okay. Here is hand. Okay. Let me just. Okay. Okay. You're welcome. Whoever enjoyed the food. Fathiya, please write your question in the chat. Yes, we can call it a technical error or an artifact. Yes. Okay. So okay. So now for the questions, what I'll be doing, I'll just unmute the participant so they can ask their question. I can hear it. That would be easier, right? Because everyone is writing on the chat. So just give me 1 second. I'll allow the participants to ask their question. Just see how we can do it. Just 1 second. Okay. So technical difficulties, sorry for that. Okay. Okay, now, whoever has a question, please raise your hand and I'll receive your question. Okay. So I'll start by the first one. Now we will be Affan. I'll allow you to speak. First, allow Dr. Qais to.